Hi everyone, thanks for grokking. We're going to look at 3-sum LeetCode 15. We'll start by looking at the problem statement. If you don't understand the problem, you won't be able to find an optimized solution. We'll discuss a naive solution and then take a look at an optimized solution using the two-pointer strategy. However, and remember, we're here to learn and not memorize. So let's go ahead and take a look at the problem statement. I went ahead and underlined a few things that are good callouts. First, the data we're going to get, it's an integer array of nums, and looking at the input, it could be negative, it could be positive numbers. We want to go ahead and return a list, and specifically a list of lists that contain three numbers, I, j, and k, all that are indexes based off our original list, that equal a specific target, in this case 0. And lastly, and this is very important, our solution cannot contain duplicate triplets. So that means at some point we're going to run into duplicates. We have to figure out what to do with them and how to add them to our final solution properly. Now, depending on how experienced you are, I do feel like this problem statement does try to trick you, specifically with the I, J, and K. Anyone familiar with some programming or just form or logic knows I, J, and K are just very simple looping variables for I, for J, and for K. And you can absolutely solve this problem just like that. Have three separate for loops, I, J, and K. J is set to I plus 1, K is J plus 1. Look at the three values, check if they equal our target 0. If not, just increment by 1. The only issue with that is it's going to be slow. 3 loops should immediately set off the signal in you saying, there's a better way to do this, and I need to find it. 3 loops going over a list is O n cubed, and any moderate size of data, that's going to take a while to run. So there's a better solution. It's called using the two-pointer strategy. And remember, when I'm talking about LeetCode and Python within this type of like interview tactic strategy, in your head, just think pointer equals index, because that's all these are, especially in Python. We want to find 3 separate indexes that, when added together, equal our target 0. And then we're going to actually use a very similar strategy to what we did with LeetCode 125, valid palindrome. So let's go ahead and take a look at an example I have. So one thing we can do in any of these problem statements is, how can I manipulate my input data? Initially, it's just a random list with random numbers in there. So that's why you might think, oh, I have to use 3 for loops to get everything in every possible combination. However, if we spend a little time up front doing some pre-processing, we could go ahead and sort our list. So this is how our list would be sorted in ascending. So everything on the left-hand side of the list is smaller. Everything on the right-hand side of the list is bigger. So that's where our two pointers will come in. A low and a high pointer depending on where we want to move. And then we have a separate pointer just keeping track of what we're currently looking at. And those 3 values will determine our triplets. So let's play this example out. So our current value will be at 4. Our low pointer will be at -1, -2, and we sum these 3 values together. So we would get -3. We see, hey, that's not equal to 0. So let's go. We change our current value to be to -1. We change the left-hand pointer to be 1 to the right, -1. And we change our right-hand pointer just to stay there, because we haven't done anything to the right-hand side yet. So now let's add these. -1 plus -1 plus 2 is 2. Okay, so we need to go down a number. So we take our right-hand side. 2 is too big. Let's go down to a smaller number. So we make our right pointer go down 1. Okay, so -1 plus -1 plus 1 is 1. So we're getting closer to our target. So we're still too big. Let's see if we could go down one more number and find a value. So now we have -1 plus -1 plus 0, and that gives us our value. And we can see that's a solution right here in the example. I think this will be a lot more clear once we're actually looking at code, but a very important part of this is you have to sort the array up front. If you don't, your options are a lot more limited, and you just made something difficult for yourself. So that's a very good call out for any type of leak code based interview problem is what can I do to the data initially to make it easier to search, to make it easier to manipulate, to make it easier to just look things up, whatever it might be. Okay, let's go ahead and jump into some code. Okay, let's look at some actual code now. I have a function definition for us. Nums is what we expect as an input, a list of integers, and we expect to return a list of integers, and this is our triplet representation. I also went ahead and wrote a solution summary for us up top. That way, if you're ever confused between the code, you could pause, look at the solution summary. I tried to write it in just plain English, almost like a recipe, and then if you're still confused after that, leave a comment and I'll get back to you when I can. Taking a look at the summary, first thing, we have to order our array. Unless a problem statement specifically says so, always try to think, how can I manipulate this data structure to make it easier on myself? Random, unordered data is very difficult to search. It's very difficult to find things, but a data structure that's ordered in some way, you now have a way more options. So after we order our array, we're going to set up 2 pointers, low and high. Low represents the left-hand side, low numbers. High represents the right-hand side, high numbers. And with that, we're also going to be looping. We have an index plus 1. So with our index, a low pointer and a high pointer, we just got 3 elements. We could sum them together, and now we could actually start doing comparisons. If the sum of the triplet is less than our target, and our target is just 0 in this case, we want to move the low pointer forward or increment by 1 because we're hoping to find a slightly bigger number. That way we can add it to the new triplet set and hopefully that equals the target. And then the opposite is also true. If the sum is greater than our target, then we want to move the high pointer backwards or to the left because we're hoping for a smaller number that equals the target. Now, if the sum is equal, awesome, but we're still not quite there. We first have to check if it's a duplicate. If it's a duplicate, throw it away, keep cycling. If not, gangbusters, add it to the triplet list, and finally return our triplet list. So let's actually begin. Let's take our list and let's go ahead and sort this. And not to get too much into the weeds, Python's built-in sorting mechanism runs in n, log n time. Very quick. I promise you're not going to write a sorting algorithm faster than this. There's a reason why it's built in. Just go ahead and use this. And now we know we are going to be returning something. So let's go ahead and name triplets. And we'll just make an empty list for now. So looking at the solution summary again, it does say we want our current loops index plus 1. So we are going to have a for loop in here. Let's do for I in the range of our nums list, length nums. Okay, now let's go ahead and set up the actual pointers and our current value. So the current value is just equal to I. That's where we currently are looking. So nums I. Now to set up our low pointer, that's just equal to I plus 1 because our current value represents the present. So we need to look 1 to the right. We need to look at neighbor. And then our high pointer is equal to the length of nums minus 1. And remember, it's always going to be minus 1 because we do 0 index counting in Python, 0, 1, 2, 3. So we need to make sure we actually get the appropriate length, so minus 1. Okay, so now that we have 3 triplet values, we can start doing some math. But we need to compare, oh, what if it's this value, this one, and that one? So it's not quite perfect yet. And if you watch the LeetCode 125 valid palindrome, if you do enough of these LeetCode problems or have enough programming experience, you start noticing patterns in systems. And this is similar to any of these 2 pointer solutions. So while our low pointer is less than our high pointer, and let's go ahead and just make a variable called temp total. So we do our current value plus nums at the low point plus nums at the high point. Great. So now we have our first triplet. And with that, we could actually start doing some comparisons. And really, you could, with how the syntax works in Python, you could pretty much copy this line and make it work. So if temp total is less than our target, let me go ahead and make a variable for target, and I'll just set this equal to 0. You could just put 0 in here. I just don't think it's not really good readability, in my opinion. I'd rather have a variable name that says target instead of just a magic number like 0 floating around. Then it's like, why are we always comparing against 0? What does that represent? So if temp total is less than our target, we want to go ahead and move the low pointer forward, hoping we find a slightly bigger number next pass. So plus equal 1, else if our temp total is greater than the target, so we overshot our value. So we want to take the high pointer and move it down. Hopefully we find a smaller number. Else if our temp total is equal to our target, great. But remember, that's only the first part. We have to check the duplicate. So if our current value nums with the low value and nums with the high value, if that's not in our triplet data structure, we can go ahead and add it. And I'm just going to copy this line to save myself some typing. There we go. So we could add it to the target. And then we still have to increment our pointers. So let's look at the next lowest and then the next highest. So plus equals 1, high minus equals 1. And ultimately, we do need to return something since this is a function. So let's go ahead and return our triplets. Pretty good. And you can see I just took the solution summary and just converted it into some Python code, which was pretty close to what the solution summary was to begin with. It was pseudocode. Okay, so now if we look at our main, I went ahead and copied the actual LeetCode example inputs here, and then I made a few other ones. But let's just take a look at the LeetCode ones for now. So let me go ahead and run this. So boom, so let's make sure, so our output here, there, that matches. We're supposed to have an empty list. If you have all zeros, just return zeros. Boom, so far that matches. So this is the 2-pointer solution. If you have any other questions, feel free to ask in the comments. You guys, if you're watching this, you know how YouTube works. Click button, subscribe, whatever it might be. And here's all the code and all the solution summary in one easy viewing. Thanks everyone. Thanks for grokking.